Hello, this is Rico with Maker's Code, and in today's video I'm going to go over the WebRTC and also object detection using the Unitree Go2 Pro. So the first thing to start off with is let's get the library that I used. So there's this Legion 1581, and he created, on top of some other things for the Unitree Go2 Pro, or in general the Go2, he created this WebRTC library that allows you to connect to the Unitree Go2. So as long as you're on the same Wi-Fi network, you will utilize this examples folder. And he has a couple example ones, so one of them being video stream. So if you were to run this code, which I have here. So let's pull up this code real quick. Go to the video stream. And he has this display video. So the first thing you need to do is if you set a specific IP address for your Go2, you would set the address here. By default, I believe this is the default one if you never set an IP address for your Go2. But make sure you're on the same network on your computer and the Go2. So in the configuration, there were two ways to set up the connection. You could either do your cell phone, making it a Wi-Fi hotspot, or you can connect to a Wi-Fi router. So I did it on the router. So now they're on the same network. And so I manually have set my router to give it this fixed IP address whenever it connects. From there in the code, you'll just run it. I'll just run this code real quick, and it will pop up a video display of what you can see as the output. And Python video. So it will display the video output of what the Go2 is saying. So if I were to rotate it, you can see that it sees video and pretty good live stream of it. So it's not too delayed, which is good. So WebRTC is supposed to be good with that. Okay. So then I took that code, and that code right there would give you this frame, this image frame. And so what I did is I said, okay, I can feed this image into different object detection frameworks. So the first one I used was actually RF-DETR, but YOLO was kind of the one that everyone falls back on as far as like a default one to try out. So you take that frame in. From there, you are going to convert it into a BGR image. And then in that, you feed it into the model. So the model was loaded here, a YOLO model. And then there are different YOLO models you can choose from. There's segmentation. There's just the basic detection model. So this just puts a square around the object. This one will highlight it. And then this one, I can't remember what OBB does anymore, but it's another one of those. It'll add additional information, I guess. So we can try that one real quick. And again, the IP address was fixed. It will load. And then in that, let me share that video because they're all different names for these video outputs. So we have video YOLO, and this YOLO one is this one. And so we have this segmentation. So now if I were to look around, ooh, something fell down. What fell down? Oh, I forgot to take the lock out of the leg. You can see here that it's seeing different things and it's marking them. And so one of the things that I was troubleshooting whenever I was doing this was the when you're moving around, the screen tearing as this video output is coming in, and I was moving, you would get a lot of screen tearing, especially with the RF-DETR one. But you can see here that it highlights and gives you a confidence level as far as what it sees. And what I found with this YOLO model is that it has about 80 things it'll detect by default. So you can see here everything is called suitcase or chair. Not a lot of very descriptive things beyond that. So it's very basic as far as what it'll detect, and you have to fine tune it to do better. So that was YOLO, and it works fine. Again, the only reason why I wanted to try something different was this 80 names that it can find. So I might be able to, let's see here. Is it here or is it in here? I think it's in results. In results, the model has this concept of names here. And you'll see that the names here only go down to 80. And you can see they're kind of random things. Toothbrush, fork and knife, and bowl and banana, and sandwich and carrot. So kind of very generic, specific things, you could say. But just walking around like a house, it's not going to see too many interesting things. It'll see cups and things like that, but it's not a huge number of objects that it's going to detect. And if it doesn't know, it just kind of lumps them all in. So then I went with this RF-DETR, and there were two different ways you can run this model. There's one where you can run a server that hosts the model, and this could be a local server. And then there's a Docker image you start, and then that Docker container contains the model, and you connect to the Docker container, and then it would feed the results from the server, or you can run the model locally. So I'm on a MacBook right now. I've been finding that these models may be more optimized for CUDA because they're not great versus the even the Orin Nano. So I have an Orin Nano here, I have Xavier, I have a Jetson Nano, and then a bunch of Raspberry Pis. And so I also ran the model on the Orin Nano, and I found it to be a lot better as far as the screen tearing. And I can show you what the screen tearing will look like in a second. But originally I was running this code using this this server, and so to get this and this WebRTC, I think it was actually the WebRTC stuff I was running into. So getting this WebRTC client to work on a Windows system with my RTX, what is it, 4090, I couldn't get the WebRTC library to work in Windows. There was something about like an Opus library, and it was becoming a pain to get it to run on there, where at the very least on my MacBook it was running. And then I have just this concept of in first state where I don't use the prediction model on every frame. I use it on, I think right now I'm up to 6 or 7, seventh frame. Yeah, so every 7 frames, I will check for any objects, and then if I find anything, I store those detections so that on the passes where I don't check, I just reuse the original detection. So the detection is always there, so I can always label. But if I'm moving really, really quick, then you'll start to see that kind of the kind of shadow effect where the image was detected previous frames, and now the frame is moved. So those objects aren't there anymore. So this was kind of a quick hack to reduce the number of times I do this model infer. That way I can get better quality. It's not so much that the code was running slow. It was more just the screen itself was tearing. So we'll try this out real quick. So we'll run this. And what's going on here? I think it's still loading this one, this model. Okay. So in this one, you have this model now. Let's see, is it using the latest? No, let me pull in the latest video feed. On the screen. So this is video RF-DETR. Windows capture and Python video. Okay, so again, under the hood, I believe this is just using YOLO also. So when you're looking at this, you're again going to see this, and you'll see here, this is the screen tearing I'm talking about, where it has to kind of keep up. And I think now that I'm using OBS, it's running a little slower, but you'll see that it detects a lot more objects now. So the potted plants, the suitcase is right this time, the couch is right. Yeah, with OBS running, this is kind of getting a little slower. So you can definitely see this screen tearing I'm talking about, where the YOLO model didn't have this problem. But you'll see it sees a TV and stuff a lot better. Chairs. Let's see if it sees anything better here. A handbag. Yeah, so it's definitely seeing things better. But you'll see this screen tearing. So one fix I did for this was, again, I just changed this. We'll make it a little bit slower with OBS running. So you can see YOLO was better at this, but at the same time, it didn't have a lot of objects to detect. So that was kind of annoying. Okay, so let's run this. I'll probably have to load that video again. On video. Okay. So you will see now here, let's see where we're at. Scoot back a little bit, we'll turn. And you'll see now that the screen tearing won't be as bad. And it's still pretty bad. I do know when OBS isn't running on this laptop also, it runs better. But it looks like it's pretty messy right now with OBS running. Wow, yeah, not great at all with OBS running. I'm not sure if I run the server somewhere else if that will improve it, but You get the gist of the fact that it gives you a little bit more, but at a cost of making sure that you have enough processing power. So without OBS running, this should look a lot better, I'll say. But right now, yeah, with OBS running, not great. Versus YOLO especially. So library also gave you some other things. So there was this in the folder, there's another one called LiDAR. So the LiDAR data you can see here. If I run this code again, the only thing I changed in this code was just my IP address. So I just changed the IP address. Everything else I've left the same. I haven't even really played with this. I didn't know there were all these arguments, but run this code. And this one runs in the web browser. So let's pull up the web browser. And let's see now. What do we get out of this one? If we refresh, you'll see now you get a point cloud. And this one is not the same as what you would see when you're using the app. The app gives you a more coarse, you can say. The boxes, the little point cloud dots are a lot larger. So this is giving you a lot more detail than what the app would give. But it's a lot. So it's kind of hard to see it all, but you can kind of see where the opening for rooms are. And then the couch itself is there with that angle and the couch. Orientation wise, I'm not really sure because it's such a slow. One bad thing about this is also the refresh on this is kind of slow. So yeah, it doesn't seem to really show you orientation too much. And since I don't really have a video feed on this, it's a little more complicated. But if I move over here, I guess. Let's see, we'll move over here. Get a little more information. You'll see that it's starting to fill up this point cloud now for what my kitchen would be. So it does a good job, but you'll see that it does have a maximum distance that it will measure. So I'm not sure in parameters. Again, I haven't really played with this one too much yet, but you can get a point cloud also with it. Now it's hard part of controlling it back into my wide area living room. Okay. So yeah, you can see that now after I've put it back into a confined area, it's starting to catch up, but it is slow. So especially compared to the video feed, the LiDAR feed is pretty slow at refreshing. But the data is there, and then it also gives you the option to save the data. So you could save the data to CSV files so that you can play them back later. So that's kind of cool. And then the other files in here are to give you kind of states. And then also they will cycle through different modes. So some of these will go through a bunch of different, looks like it was this one then, that goes through all these different modes. So it'll do a couple steps here and there and then go into the AI mode and stuff. So you can play with how to utilize different commands to tell the robot to do things. And then in your later code, you can actually make it equivalent to running like the remote control. So those are kind of some of the things I've worked with right now so far. These, again, were just quick and dirty. There was the YOLO one and then the RF-DETR. I'll put the links in the comments, but you should be able to quickly get those up and running. I also have this code on my GitLab page, so if you wanted to not even bother writing code, I put it on there. So we have on here on my GitLab Rico AI. In the, again, this would be the same thing, but I forked it. And then if you go into examples and in video, you'll have all three types. So the YOLO, the RF-DETR, and then the normal camera stream one. So you can try them out without having to do a lot of effort. These will automatically download the models. So hopefully this was helpful. If you have any comments or questions, please leave them. Please like and subscribe. If you want me to try any other object detection models, I'm still kind of up for grabs. Like I said, the Jetson Orin Nano, it worked well, so I might be okay. But if there's any others I should try, let me know. Next thing is just kind of build out this interface, because when you are running this code, if I run this code here, let's see, first I gotta mirror my, well, when you're running this code, you can also run the web app on the phone. So if I were to try to run the app to control or see the video feed also from my phone, that does not work. You can only run this code or the iPhone app, but you can't run both at the same time. So you really have to rebuild the entire interface that the app gave you, the iPhone app, if you want to use the web browser instead. There may be, again, I'm pretty new to WebRTC. There may be a way to share the connection. I don't know how that really works, but yeah, for now I know it doesn't work. So yes, hopefully this helped. Let me know. Have a nice day.